So the question is, first question, why is this topic, equalization, important for students? I think my answer there would be that, of course, the function of an equalizer is very important because, like it or not, in most communication systems, one would need to use an equalizer to make up for the effects of the channel to avoid unacceptably high bit error rates or something that would require you to communicate unnecessarily slowly if you chose not to use an equalizer. So the importance of it is of course there, but the theory of equalization is pretty inaccessible, I think, to most undergraduate students. And so if one is not able to fully comprehend all of that, well, with the EMONA system, we can implement an equalizer in the hardware, and the students can see the inputs to the system, the effects of the channel, and then the effects of the equalizer, and the results at each step, and how the equalizer has a benefit to the signal. And so even if one doesn't fully understand all of the theory, you can see the results of it right in front of your eyes. And so I think there's a lot of value there to doing it hands-on.
Interesting.
So I think that's my answer for number one.
Okay.
So something it's important to know, even if a lot of the details might be out of reach.
Okay. The step-by-step experiment procedure and background theory is fully included in the documented experiment. Each stage of the transmission model in this experiment is built with hardware circuits and real electrical signals. This second-order transfer function is built with adders and integrators. A convenient GUI allows students to manually enter and edit adder gains in real time. You can see the effect the second-order low-pass filter has on the incoming bipolar data. The incoming bipolar data spectrum is strongly attenuated by the second-order low-pass filter. We implement two second-order transfer functions side by side. The green signal is recovered from the red using equalization. Students manually adjust noise levels and take measurements whilst doing so. Match filtering at the receiver is implemented using integrate and dump blocks. Integration over a period of time requires alignment of that period. Students implement bit error rate instrumentation and take measurements of signal to noise versus error rates throughout the experiment.